Hello and welcome to Autology, the podcast that brings you the latest on automotive technology. Today's episode is called SDVs, Mapping the Road Ahead, and you're here with me, Alicia Thakkalal. Today's guests are Justin Moon, VP of Core Product Engineering at QNX, alongside S&P Global Mobility's very own SDV expert, Vivek Beriwal. Hello to you both and thank you for joining Autology.
Hey, Alicia, thanks for having me. Super appreciate it. Looking forward to the conversation.
Thanks, Alicia. Thanks for inviting.
Thanks for coming. So today's podcast is all about software-defined vehicles. But the first question that I really have is, what is the current climate like for software developers in automotive? Vivek, perhaps you can start first.
Sure. So to set the context a bit, vehicle software is a more rewarding business than vehicle hardware. That's the bottom line. In fact, gross margins for vehicle software are around 3 to 5 times higher than vehicle hardware. Currently, software makes up around 10% of a vehicle's total value, but this could go up to, I would say, 30 to 50% by 2030. In such a scenario, suppliers can't remain hardware-centric or they risk losing margins, So secondly, the arrival of the software-defined vehicle means that software is increasingly being viewed as a differentiator and not just hardware and mechanical engineering. As a result, more automakers are moving towards zonal EE architectures, central compute, unified software stacks, and over-the-air update systems. And this has spiked up demand for modular software platforms and development tools. And additionally, artificial intelligence, machine learning, and technologies like that are also being increasingly embedded within vehicle software development. Lastly, and very important point, is that it's the software that opens up recurring revenue opportunities for the automaker, be it vehicle connectivity and autonomy features, digital services, feature unlocks, service subscriptions or upgrades, and many such monetizable possibilities. This has created new business opportunities for pure software vendors, middleware providers, cloud service integrators, and also user interface and experience specialists. So if I were to put in one line, automotive software development space is really buzzing at the moment.
Yeah, that's good to know. That's a great summary. Thank you. And same question to you, Justin, but could you also please give us an idea of any bottlenecks in the industry as well from your perspective?
Sure, no problem. So first, let's take it back to the original question around what is the current climate from a software development perspective. Let's take it to the view from a developer's perspective. The overarching vehicle technology platform, regardless of ECU, regardless of architecture, this is an extremely complex software environment. In vehicle, we are solving many different challenges from a technological perspective in an environment where safety and security are, tantamount to success. Without safety and security, these cars aren't going to drive. At the end of the day, these are rather significant machines that interact with humans on a daily basis. So again, from a safety and security perspective, these things need to be first and foremost. And those come with challenges. People believe that, in the safety scope, innovation is difficult and all of those types of things. But from a QNX perspective, we say complexity is one of our true benefits, I would say, in terms of how we interact with the market. That complexity and managing it in those safety and security environments, I think, is where the true innovation lies moving forward. If we think about bottlenecks comes down to availability of talent. I think is probably one of the bigger bottlenecks. There are a lot of embedded developers out there, but there's a lot of disparate technologies that go into building a car. If you think about what a car is today, it is quite literally probably one of the first, I might get roasted for saying this, but one of the first human interacting robots, if you will. Let's think about all of the, as we stride towards autonomy, these are robots interacting with humans. So think about that complex nature and kind of that dichotomy as well. But having the overarching talent within the automotive industry to actually solve those challenges, I think is one of those bottlenecks. And it comes down to how we as a collective industry actually interact with one another. I truly believe that partnerships is the next superpower in this industry. we have to actually figure out how we collaborate together in order to ensure that those bottlenecks purely from a talent acquisition perspective are solved, making sure that we have people focusing in the right areas. So that really, I think, is one of the key focus items that we have moving forward, is about how do we enable that stronger ecosystem so those bottlenecks kind of disappear.
Yeah, it's interesting you say that, because I remember having this discussion on ontology previously when we were saying that this sort of software education needs to be as part of the curriculum for automotive engineering to really get the ball rolling. Yeah,
we're making strides in that regard as well. We've been working with a lot of the very prolific education centers in North America, as well as a very broad reach in Southeast Asia as well, around actually getting access to our technology and building automotive-centric curriculums leveraging QNX technology. And, we're well on our way to some very positive things there. So Alicia, we're completely aligned in that. It does come down to, how do we work directly with academia as an industry?
Yeah. Do you think that will be like in time for the SDV revolution, or do you think it's going to be quite delayed?
Software definition's already here, right? We're talking about a level of complexity that we are tackling today. Do I think that there will be the talent? Yes, I believe the talent exists today. Absolutely. What we have to do is build more. We have to have more. There are going to be more challenges moving forward. We're not going to solve the complexities of today with a future outlook. Who knows where as we grow from an autonomy perspective, there are more sets of innovations that can occur even from a safety perspective around fail operational and things like limp home mode and all of those things people have been talking about for a long time. I think from a talent perspective, we can solve the problems that we have today with the talent pool that we have today, but then it's what's next, right?
Yeah. Oh, it's good to know. And Vivek, perhaps for a bit of context, it would be interesting to know what OEMs are at the forefront of developing SDVs at the moment. Who's the front runners in putting this technology on the road?
Yeah, if we break down the current SDV market, Alicia, there are essentially three main types of companies. First is leaders or front runners. That is those automakers who have central compute architectures, high frequency OT updates, and strong in-house software stacks with full vertical control. The likes of Tesla, NIO, XPeng, and to a large extent Mercedes-Benz. These companies fit this bill. Then there are emerging players, mainly legacy OEMs who are investing heavily in this space and trying to move towards zonal architecture and central compute, but are yet to make the full transition. Examples for this case would include, companies like Volkswagen, Stellantis, GM, Toyota, and the likes. And lastly, there are techno collaborators, companies who are mainly reliant on SDV ecosystem and suppliers, for instance, Ford, Honda, Mazda, and so on and so forth. So yeah, if you ask me who's leading, the SDV development scenario at the moment, I would say it's always been Tesla, and Tesla is kind of continues that, and you can also say some of the emerging Chinese EV startups like NIO and XPeng. I would love to tell the audience that S&P Global Mobility has developed an SDV readiness level benchmark that kind of provides a comprehensive framework to assess a vehicle's software readiness. So it categorizes every vehicle from level 0, which means not software ready at all the way to level 5, which means it's fully software ready. It's an approach very similar to SAE's autonomy levels. So this index is based on extensive primary research and industry feedback from various stakeholders. It's mainly based on three foundational technologies, which is over-the-air capabilities, EE architecture, and lastly software components. And it basically analyzes as many as 35 technical parameters at the vehicle level, such as data handling efficiency, resource allocation, communication protocols, and cybersecurity measures. Yeah.
Okay, great. That's good to know. And then from your perspective again, Justin, how is QNX working with different stakeholders like the OEMs, the tier ones? And I'm not sure, are you seeing more partnerships with like the like hyperscales like Azure, Google Cloud, or connected services, for example?
Well, I kind of let my punchline go at the very beginning when I said I truly believe that partnerships are the next superpower as far as I'm concerned. I mean, you can look at kind of what we're starting from a groundswell perspective with a company like Vector, where we're looking at truly foundational software and what does it mean to provide that foundation for innovation in safety and security environments. We work with, the overwhelming majority of OEMs and tier ones and technological players in the automotive space today as a foundational component. Obviously, we touch a lot of different ECUs and a lot of different facets of the industry. It's kind of a mixed bag, I would say, in terms of partnership versus commercial/customer agreements. But as we move forward, there are, many different avenues for ecosystem development, whether it be in the open or what we call commercially open, wherein we have IP that's available and can be leveraged for use in vehicle. Where it comes down to, I believe, when I keep saying partnerships are the next superpower, it comes down to transparency in the industry, understanding what everybody has, creating the appropriate business model so everybody can be successful. At the end of the day, we want vehicles to sell and we want to be able to, be successful from a business perspective, not just QNX, but industry-wide. So understanding all of those non-technical challenges, I think, are also something that's extremely important and shouldn't be overlooked. Like, what does it mean to commercially work appropriately together? What does it mean to be legally partnering and solving some of those industry challenges therein? If we think about it in terms of a safety/security certified environment, there are a lot of challenges to having multiple companies partnering, working on something that could be collectively safety certified. So again, understanding those industry challenges and solving them also helps expedite kind of all of the things that Vivek had mentioned in terms of the features that are being monitored and all of those types of things in terms of the report. Without building these foundations, without building these really strong partnerships, it takes a lot more time. It gets a lot more complicated in order to satisfy those features. So yeah, in my view, again, it's a mixed bag, and partnerships are the next superpower. I'll keep saying it. I heard it once from somebody. I forget where it was, so I will not take full credit for the statement, but I think that it rings true.
Yeah. So if we take the flip side of that, I guess you guys would face competition from stakeholders like traditional RTOS vendors, chip makers, etc. I mean, looking forward, what's QNX's biggest bet in maintaining its share in the SDV space?
So if you look at true foundational software and the stacks that exist in a vertical environment, there's a lot of software between somebody doing something at a high level from an application perspective. And I don't mean phone applications. I mean an application of vehicle technology like a perception engine or something like that. There's a lot of layers of software between that doing something and it hitting a bit in the hardware somewhere. So less a bet, more a strategy. At the end of the day, I'd mentioned how complex these systems are, and they continue to increase from a complexity perspective. Strategically, as part of the industry-wide initiatives, we're looking at what does it mean to actually manage that complexity appropriately. What does it mean to abstract from a performance perspective as opposed to abstract for an abstractions perspective. We want to make sure that we're creating foundational layers of software with APIs that make sense, as tightly coupled to the operating environment as we can. Because as we look at these multiple layers of software, the biggest thing that comes out of it is, well, we have to manage latency as well. Latency management comes with, well, how many cycles of the CPU am I using for any particular endeavor in the system? We need to make sure that we manage the amount of code that's using those CPU cores moving forward. So again, we're looking at strategically around complexity management. We're looking strategically around what does it mean to partner appropriately to solve industry challenges. Now, again, with Vector, for instance, and what we announced in the foundational vehicle software platform is solving those low-level, truly found complexities that we've together witnessed and faced in many startup productions over the years. It's around extremely performant communication stacks. It's around latency management, overall system lifecycle management, configuration from a unified standpoint, diagnostics and logging from a unification perspective. It's very low-level intrinsics which allows the first tiers, the second tiers, and the OEMs to innovate above that. The idea is solve all of these low-level problems that, to be perfectly blunt, a vehicle driver isn't going to care what diagnostic stack they're using. They're not paying more money for a unified logging experience because they will never see it. But what it does allow is, again, when we come back to the talent base and you had asked, can we actually satisfy with the talent base that we have today and the number of resources that are available today? Yes, I believe with focus, where in the first tiers, second tiers, and the OEMs are focusing on their true value add to their true customers. Yes, absolutely. And those are the kind of the strategies and things that we're looking at in terms of solidifying our position. I mean, we are in a very blessed position, I would say, in the automotive space today. We've done a lot of good over the last 40 some odd years we've been in business. But I think that, again, it's about fostering those relationships. It's about helping manage complexity and really truly allowing folks to focus.
Yeah. You mentioned strategy there. Vivek, we've seen here how software developers are kind of going down the route of regionalizing their strategies. How are they developing now? Is it still the same case?
Yeah, that's kind of true, Alicia. Automotive software developers are increasingly adopting regionalized development strategies because software needs to align with local regulations, user expectations, connectivity infrastructure, digital ecosystems, and even cultural nuances. Vehicle software, it's safe to say that it's no longer one size fits all. So several technical, regulatory, and customer-driven factors are pushing developers to adapt software and digital features to specific regions. Uptake of connected digital services relies heavily on local market factors as well. For example, voice assistance, in-car navigation, audio and video streaming services, in-vehicle commerce, and infotainment systems. They all require support for local languages, dialects, accents, and content providers. In some markets, for example, mainland China, it is mandatory for software developers and automakers to comply with data privacy and cybersecurity laws. So, in a nutshell, we can say automotive software companies are increasingly deploying quote-unquote global SDV platforms. That is a mix of global and local. They kind of combine globally standardized software core with configurable overlays that can be tailored to a particular region. This approach is managed via cloud orchestration and OT updates to allow for regulatory agility and regional user engagement without fragmenting the core software platform.
Thank you for that, Vivek. And has that been your experience at QNX, Justin?
Well, regionalization isn't anything new from an automotive industry perspective. There's just a lot more configuration options today, right? I mean, there's always been regionalization from the international vehicle manufacturers that ship in the various different regions globally. But again, the complexity management of the number of configurations and the fact that there's a lot more software in the vehicle now does make it a little bit more difficult, for sure. But again, I mean, the big OEMs of the world that ship everywhere, they've handled this type of configuration for decades. It's just a different software experience now.
Great, thanks for that. And moving on, cybersecurity vulnerabilities are expected to be the biggest risks to SDVs in the next 5 to 10 years. Is that concern justified, Vivek?
I would say to a certain extent, yes. Cybersecurity, including data protection, that is definitely one of the biggest, if not the biggest, risks to proliferation of software-defined vehicle over the medium term. We all know how the Jeep Cherokee hack back in 2015 acted, kind of wake-up call for the industry, turning cybersecurity from an afterthought into a core pillar of modern vehicle development. So cybersecurity is without doubt one of the most existential risks for SDV. However, that said, SDV failure is most likely to come from software complexity and execution gaps. Let me put it this way. SDVs won't scale if cybersecurity fails, but SDVs can't be launched in the first place if software engineering fails. In fact, integration failure is cited as the number one cause of SDV launch delays. And the reasons are obvious. Compared to legacy vehicles which used nearly 100 million lines of code, automated and connected SDVs today need somewhere between 300 to 500 million lines of code. And additionally, ongoing OT updates intensify this complexity even more, meaning, what it essentially means that software never reaches a finished state, so to speak. So cybersecurity vulnerabilities have always been there and will always be there. But with SDVs, the stakes have risen considerably. So yes, in terms of the biggest risks to SDV rollout and expansion, cybersecurity is right up there. But I would personally rate software complexity and integration challenges a notch higher than cybersecurity concerns.
Yeah. Okay, that's interesting. And Justin, would you agree to that?
Obviously, cybersecurity is extremely important, SDV or otherwise, or automotive or any other industry. But really, what it can come down to, and Vivek, you kind of you hit it the nail right on the head when you said software engineering can't fail. Really, where it starts is culture from a software development perspective. We have to make sure that from the CEO of these companies that are delivering software into these regulated industries down to the individual contributor, live and breathe a safety and security culture. Although different, I don't think you can speak about cybersecurity without bringing safety into the fold as well. Obviously, the challenges are different from a technological perspective, but you can't have one without the other. So again, technologically, we can put all of the layers in place and all of those types of things, but without truly identifying a cybersecurity and functional safety culture within a software organization, it becomes incredibly difficult to deliver, and the risk of software engineering failing increases without that culture.
Agreed. Yeah.
Okay, perfect. And then in addition to cybersecurity, AI is another hot topic of late. Vivek, how do you envisage its role in SDV development?
Yeah, AI is, as you said, into everything, right? We cannot survive without AI. Like in most industries, it's become core to SDV development as well, and not just a side capability. So for SDV development, I think AI can auto-generate code for middleware, ECUs, and HMI. It can enable model-based development at scale and can also speed up development cycles. It can play a huge role in validation. Say, for instance, AI-based scenario generation for driver assistance and safety validation. It has a role to play in cybersecurity and threat monitoring. AI-based intrusion detection and security patch automation are being deployed somewhere as we speak. AI-driven analytics for homologation compliance is another popular use case. AI is also being used for optimizing OT update schedules for bandwidth, cost, and customer convenience. So yes, AI can boost every phase, of the SDV lifecycle, be it architecture, development, testing, deployment, and operations.
Okay, understood. And Justin, I've got QNX's Under the Hood SDV developer report here. For the audience, this is a survey that was sent out to over 1,000 software developers globally. There seems to be a kind of unanimous recognition among developers, in your report it says 80%, that their efforts are better placed on application layer innovation as opposed to foundational infrastructure. I mean, how do you see that playing out in the real world these days? Would you say that OEMs have come round to the fact that they don't need to build out the full stack themselves?
Great question. I will use my favorite safety answer, and it depends. It's about return on investment as opposed to capability, to be honest. I believe that there's an industry-wide recognition that focus is needed in order for everyone to satisfy the overarching need from a consumer perspective. Whether that breaks down into where the OEM places their software budgets, that I won't comment on because I don't work for an OEM. But I do believe that there's a wide recognition that focus is key. And you'll see from that report that it wasn't just the individual developers that commented on that, but also up the management chain as well, that said focus should be, and it says application, but I'll make an equivalency statement and say application equals value to the end customer. So there is obviously a direct correlation to the developers, the managers, and the focus on driving, the consumer experience, let's say.
Okay, understood. That's great to know. And just before we wrap up today's episode, it would be interesting to know what each of you think what a successful SDV ecosystem would look like, say, 10 years from now in 2035. Vivek, you wanna go ahead first?
Yeah, sure. It's not an easy question to answer, Alicia, but yeah, I can try. I think it's incredibly difficult to predict given the pace of developments in automotive. But 10 years from now, I think the industry will be strongly driven by a software-first, AI-native ecosystem where vehicles will evolve continuously through the cloud. So vehicles will probably completely shift from hardware products to AI-powered computing platforms and hardware life cycles. And I would say around 70 to 80% of vehicle functionality should be software delivered by 2035. Generative AI is also something that I see likely becoming the primary user interface by then. Intelligent in-vehicle agents will replace menus and buttons. Multimodal interaction, which is a combination of voice, gaze, gesture, and even haptics, will be a standard feature. And real-time personalization based on the driver's identity, mood, and routines will be more commonplace. Another aspect I see is the revenue. Vehicles will probably become lifetime revenue streams, not one-time sales. And I see at least 30 to 40% of OEM revenue will likely come from software and services by then. Another aspect is App Store models. I think App Store models will emerge, which will be OEM controlled for safety layers and will probably use third-party apps for infotainment and convenience. Then lastly, I would say the architecture side of things, zonal architectures will be more prevalent. Standard automotive Ethernet, a combination of zonal architectures and automotive Ethernet will likely be everywhere, while multiple operating systems, for instance, QNX, Linux, Android, hypervisors, they will also coexist. So that's my take.
Interesting. It's great to know. And Justin, do you envisage my car turning into my home cinema or something different?
I joke about this a lot. If I had a crystal ball to know what happens in the future, I would be an extremely rich individual. So I don't make predictions, but what I will say is in order for the industry to realize or capitalize on the potential that exists from a software-defined future, we need to work as an industry and collaborate appropriately to ensure that we have the appropriate focus at the various levels so that we can deliver on the ultimate promise that software definition is. We have to ensure that the safety and security cultures are well defined and well utilized across the board. Else, everything from a feature set perspective and architectures, all of that stuff kind of doesn't matter if you don't have that safety/security mindset. So I believe, again, partnerships are the next superpower. I'm determined to drive this into the industry and making sure that we are all, headed down the same path in terms of where focus should be.
Great. Wonderful. And on that harmonious note, thank you both for joining today's episode of Autology.
Thanks for having us.
I appreciate it greatly.
And thank you to all you listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our autology@spglobal.com email. And you can find out much more at autotechinsight.spglobal.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest Autology podcasts. And we look forward to you joining us again in the next episode. Bye for now.